basically, what we are covering here have been already covered in the, but right now I'm gonna cover what we have actually done last week, so you could actually start posting questions. What I'm expecting from you is that you thanks a lot, Ahmad, as well. I would like from you that you watch the materials, try them out at least, and then when you come to this class, basically we're gonna convert it into a Q&A class. Although I'm gonna as well say a couple of words, let's say a page of words about what we have covered last time. But basically, the purpose of this online consultation is not to repeat what's already have been covered in the materials, but to help you out, guys, in case you are stuck somewhere. All right. So let me go ahead really quick and show you what we have covered so far. We have covered. I know we are not going to work with Windows Forms. I think this class, maybe the next two, we're gonna have console. Maybe one or two, and then the rest is gonna be Windows Forms, and it's gonna be tons of fun. But I want you to just to concentrate and focus to breathe and drink the parts where we are covering the console, the basics, because yes, I'm gonna say exactly what we're gonna cover today, Vlado, in a second, because the basics which we are covering here in the console application programming, we're gonna utilize same ideas in Windows application. Maybe you will not see it right away, but for example, let's say once we dig into Windows application, let's say third or the fourth class, suddenly you will see that the stuff which we have worked on in the first or the second class on console application, we are revisiting them again in Windows application. So that's why it's very important that you guys, how can I say, familiarize yourself first with the concepts without having a lot of crowdy kind of concepts that are coming out as well from Windows Forms with C#, exactly. All right, so what we are covering today. I was planning to cover with you the boxing and unboxing, difference between value types no, we are not going to work with that today. Not anonymous objects. Actually, there's going to be anonymous objects, anonymous functions, extension functions, delegates, I think, and delegates with all their kinds. All of them, we are actually going to cover them right away in one class. All of them going to be compressed in one class, and it's going to be, how can I say, a lot of concepts to be crammed into one lesson, but I think you're going to survive it. The one which I'm talking about, the boxing and unboxing, the for each loop, working with collections and all these stuff, yes, we have covered in the last actually class, yes. Oh, really? Hang on a second, Vlado, are you a regular student or are you talking about the okay, but I'm talking about the online classes, because because what I said already, that we're gonna cover I'm gonna cover what we have done last week. So people who have questions about what we had last week, you can actually ask them right here. If you didn't manage to ask them on class, once you tried them on your own, you didn't find out, you're stuck somewhere, this is the purpose of this class. I will just make a quick overview. No, I won't go very deep. I'll just make a quick overview for people who missed out the class as well. So if somebody has a question, somebody is stuck somewhere, you can feel free to ask, and I will actually start, answering the question in many different ways, as long as you have to have a full, complete understanding of covering all that which we are covering. Okay, Vlado? Yes, feel free to ask. Yes, we're gonna cover it right now. In a nutshell, right now we're gonna cover it right away, right now. Okay. This you see, as you can see, this is the purpose of the class. For those who didn't get it from the first time, or for those who saw the material, tried, didn't, you know, work out and everything, we're gonna do that right now. So Vlado was asking about the boxing and unboxing and typecasting. Okay. First of all, let me make it clear here. Value types are the basic primitive types. These types which are passed basically by a value. Okay. So if I have already covered it in the regular classes over here, and I usually say I made a small function which is an incrementing function for an integer x, and here I just simply say console.writeLine, and here inside increment. Okay. For those, this is concatenation of the strings, so I'm just here gonna put it between the brackets just for you to be not confused. Basically, it's syntactically correct. I could do oops, sorry, wait a second. Visual Studio is having fun with me. Okay, I could do this and it will be just fine. Okay. However, I'm gonna leave it that way. Now, and I said already before that if I have a 10, if I define an int I, an I now of a type integer, it's actually a value type right now, a variable which is a value type, which can be passed always by value, by default. Now, if I say console.writeLine before increment, and then I call the increment function, and I will pass to it the I, and I will say after increment. Oops, sorry. Let me just I. All right, we are good to go. And I think we are good to go. So basically the effect, as you might already have guessed, it's 10 for the first one, 11 which is inside the increment, and then 10 when it's outside of the increment, even after the increment. And this is because a copy of that value has been incremented, and this is it. So basically you had a copy of that value right here. It's not the value itself, it's a copy of it. If you would like to pass it by reference, if you would like to force that reference part, you should say ref. And once you say that I'm passing here by reference, you have to say explicitly as well that you are passing the I, but you have to say ref at the beginning. And if I hit Control F5, you're going to get 10, 11, 11. And this is because right now you are modifying the variable of that, which holding that reference. It's not like yes, exactly. So basically in C++ you had this, you have to pass this. So to say right now it is a reference. Right now in C# you just simply say ref. There's also a very cool feature called out, which we're gonna cover probably later on, maybe very much later. It's gonna be some sort of like a bonus of some sort, because you will see it only in production probably. Okay, now. This is for reference. This is actually, sorry, for value types. Let me hit end, and let me. Actually, I will define a very small class over here. Oops, it's in fact like this, and I'll have a public string name and a public int age, and because the compiler will generate a constructor for me, I will not have to type it, although I don't recommend it, but anyway. And here I'm gonna just have a person p equals to new person, and I'll just say p dot name equals to Muhammad and p dot age equals to 3 nines, whatever you would like to have it. And then I will just simply change the variables here. So I'm just going to say this is going to be P, and this is going to be P, and this is going to be change, and I'm going to as well change that. Sorry, to change. Okay? And it's going to take person. Can you move the cursor? Sorry, there you go. I'm sorry, sometimes I forget it. And right now, inside change, I'll just simply flip the name over here. So I'm going to just simply say x dot name equals to okay, Imad, sorry man. I just was looking at the chat, the first name I got, so no hard feelings. And x dot name. Okay. You're 99 years old right now, so be happy about it. You survived almost a century. Yes, you are special now. Okay, now, if I hit Control F5, oopsie, I forgot to say, I will just simply monitor the name, dot name, and I'll hit Control F5 again. All right, so before the change it was Muhammad, and then inside the change, I already changed the person name to Iman. Even change, we already have got, we have already kept that change, and this is because all objects are actually being passed by reference. All of them by default are actually passed by reference. So this is basically the main idea about it. Hang on a sec. Just a second over here. Okay. Okay, let me go over here. And now let me based on, okay, Vlado is writing something. Is there a way to specify when creating a new object that will be passed by value? I think you cannot actually say that. You have to, as far as my knowledge goes, I think you have to create a copy of it manually. So you have to create a new object, grab that thing, pass it piece by piece inside the other. So you can override it. You see, you have to do something like this. Person copy equals to, I think it should be like that. I think. And if it is not, let me see. Let me just try to undo this. And okay, and I will just simply say person. I'll just make a small test because honestly I cannot remember right now. Hang on a sec. Person second copy equals to x, and let me see if it works out. If it doesn't, then we're gonna have to copy it piece by piece. And person actually console. Let me just copy this. It will be easier, right? Control C, Control V, and let me see, second copy. So basically a second copy should keep the name Muhammad, by the way. So let me see. Nope, it didn't. So basically I got, well, this is actually again referencing operator. So I think you have to create a new person. So you're gonna have to create a new person out of it, and then you say second copy dot name equals to x dot name, second copy dot age equals to x dot age, and then hopefully second copy. Hopefully right now we should have fun, I think. Yeah, you see? So right now it works. We have to really copy it piece by piece. Yes, basically yes. This is how, if you would like to enforce working by value. So right now, for example, I will not modify even X, and I will modify this guy, and I could even return it, you know. So right now, the person P which I've created, which is Mohammed, I can even keep it still in my memory, and I will keep as well the new one, which I have actually modified. Usually people, in these cases, people they implement a cloning function inside that class. So if you'd like to duplicate it, people write a public person clone or copy, and then you give it a person P, for example, and then you say person temp equals to new person, and then you say temp dot name equals to P dot name, and then temp dot age equals to P dot age, and now you say return temp. This is basically what people do. Yes, an evil cloning. So that's, as you can see. So basically, if you would like to do that, this is how to. If you'd like to copy an object, to make a copy out of it, and as well as if you would like to enforce this feeling of passing by value, you could do that. Although I don't know. I mean, why you would make a function for that purpose? Probably you would make a function that does something else, like this. But not forcing an object to be passed by value, basically. It's like constructor. Yes, it just simply takes an object, constructs for you a new copy of that object, and this is it. Okay, so I mean this is the correct way of solving copying functions, copying objects. This is, you know, the best. I think a lot of collections have has the cloning function. And I think you have already an interface for that as well. I think iClonable, I think. Let me see here. iClonable, which has cloning. There you go. So you just implement the iClonable interface, exactly. So you have that too. And once you implement the iClonable interface, anything in .NET Framework which utilizes the clonable kind of clonable capable objects, then you can just simply use it. So .NET Framework has this built in for you, so it's kind of nice. All right. So let's carry on. So this is basically the difference between value types and reference types. Reference types are always passed by reference by default. Value types are always passed by value by default. This is basically how they could be in fact differentiated. Also, I wanted to show you. Hang on a second. There's also a page about this. Value types versus reference types in MSDN. A data is a value type that holds the data within its memory allocation. Value types includes the following: all numerical data types, Boolean chars and dates, and all structures and enumerations. Reference types, the string. I just forgot, by the way, to tell you these guys. A string could behave a little bit like a value type for you, but it's actually a reference because it's quite huge. I think if you would like to hold it in the stack. By the way, a value type is usually allocated at the stack, as you already know. The reference types usually allocated as well on the heap. Okay. So all arrays, any classes that you create, or the classes that you use in .NET Framework, all of them are reference types. Delegates as well are reference types, and we're going to see that later. Okay. So this is, for those who just forgot or may forget, this is a nice webpage. There you go on MSDN. Read it. It's really cool. MSDN is a very, very rich, extremely rich resource, by the way, for learning C# and gives you all the nice tips and tricks. Now, for those who have been in my class and they had a problem with boxing and unboxing. Oops, actually I had to shift end, but I was keeping shift home. Okay. Now, with the capability which we have got in .NET Framework, that people, that all classes which you create and any class that exists in .NET Framework, they in fact have inherited from object class. Okay, so and since that happened, sometimes you could run into very interesting things like this. If I grab our I, which is currently, this is the letter victim in our today's class, so it's I, always the victim, and we're gonna make it 10. And for a moment here, imagine that you do this. You could, because it's anyway, it's or object, both of them are the same actually. This one and this one, by the way, is the same. Okay. It's just a synthetic sugar, if you know what I mean. And if I say, if I call this an OBJ, or O, whatever, and I can put it like this. Now, object is a class, and this is a value type. Now, I put a value type inside a reference type of object. Basically, this operation is called boxing. Okay, so I took something, took a value type, put it inside. By the way, does C# has a class called integer? Does actually, this is the one. If you would like to refer to something like this, that's another. If you explicitly say 32x equals to 30, I don't know, but it's pretty much the same. They are all classes actually. All of them are classes. But just, if you know what I mean. Let me see, can I, there you go. Actually, sorry, an int is a struct. Hang on a sec, let me go back. So, there you go. An integer is a struct, sorry. So that's why it's actually a value type. Object is a class, so there you go. There you go. Object is a class. Are we good? Didn't see it. What exactly did? Well, anyway, object, yes, object is in fact a class, and integer is a struct. So that's why it's a value type. As you already have seen in the definition of Microsoft's documentation, actually, even numbers are referenced. So structures are actually are in fact a value types. Okay. Now let me go ahead here. So this is called boxing. Now, what we need to do is we would like to retrieve that thing again. We would like to get it back. So basically, the reverse option is called unboxing. However, once such a value type being boxed inside a reference type, we have to know what is inside that reference type, the type of it, so we can unbox it correctly. Because let's say if you have a float, and your float j, and you're trying to unbox it like this, float of obj, you're into a problem right now. Right now you are casting from an int. Right now you are supposing that whatever inside that obj is in fact a float, not an integer. So you have to be knowing what sides inside. It should be one 10.0 now. Indeed, indeed, indeed. Let me try this away right now. So console right line J. Oh, actually, it shouldn't because it has to cast an exception. You can from it's not a valid. You haven't specified the you haven't specified the correct unboxing way of doing it. Basically, it has to be. This is bad. This is very bad. Now I think it works, but right now it's 10 because the 0 is neglected. The point 0 it didn't write. Anyway, it works right now. But anyway, performance-wise, this is bad. You shouldn't do it. So basically, what you should do. Okay. To always know what's inside the box so you can unbox it correctly. If you don't know what is inside the box, you will always get these exceptions, and this is really, really bad. So this is basically the difference between boxing and unboxing. This is what it's all about. Email, got it. Great. Is there a way to dynamically unbox? There is a keyword as far as I remember, but I cannot remember how it behaved because I tried it once and I don't know if it will work, honestly. There you go, it works. No, nope. But this is it. This is it. This is the dynamic keyword. However, right now it's a really bad idea because performance-wise, it's a very huge hit. Because because for the program to determine in runtime what kind of an object is being passed, these checkings, additional safety checks, makes it a huge problem in terms of performance. Because right now, instead of you know what this object is and you're going to perform all the operations which you need on it, you have overhead of checking, are you that guy or aren't you that guy, and then you move along. So it is always advised to keep it really as how can I say, as simple and straightforward as possible, especially in terms of object-oriented programming. For example, I will cover generics this week. Basically, for you guys, it's going to be a consultation for you the week. Actually, sorry. This week I'm going to cover, yes, this week I'm going to cover generics. The next week for you guys is going to be revising generics. In C#, you are not allowed, when you create a generic type, you are not generic arithmetic. You cannot say, I think in C++ you call it template classes. If I, for example, create a public class vector, okay, and that vector happens to be of type T, okay. Right now, a vector could be a float vector. By the way, a vector, I'm talking about the mathematical vector, which has a direction and a magnitude, okay. So if you are saying, for example, that I'm adding two vectors, you cannot say T plus T. No, don't worry, no math. But I'm just simply saying if you are adding two vectors and you're saying T plus T, it is not allowed because it is the generic arithmetic is not allowed. So basically, people will resort to using, for example, dynamic, which is gonna be time. Should we specify the operations for them? No, you cannot, because once you specify this, it's only allowed in C++. It's not allowed in C#. So people sometimes resort to this. However, this is very huge hit on performance because imagine that you are dealing with, let's say, 10,000 vectors. The system will just slow down tremendously. So that's why we usually tend to create a new class for vector, integer vectors, floating vectors, and so on and so forth. Okay. But this is for unboxing dynamically. I don't know if you would like to do that, honestly. Anyway, there was another problem coming out from this part about talking about unboxing or casting. Oh, sorry, let me talk about casting here. I forgot to cover that. This is boxing and unboxing, which happens between, hang on a second, let me just keep it on right away. Let me undo all this. Okay, so I'm gonna keep this integer, and I'll put end here, unboxing. Okay, why do you use walkboxing? What for? Okay, good question. This is what I actually cover in a second. Just Vladimir, keep that question on. What is why we need boxing and unboxing in general? Just keep it that in my attention. And then once I come to the collections, working with the collections, you will see it in action right away. Let me show you this. Basically, a casting here is happening between two reference types, public I'll just keep a string name here for a second. I don't know if I'm gonna use it. Okay, so if I say this, I didn't need even to create a variable for it, but who cares? And if I say an object obj equals to person, or actually p, this is called typecasting. By the way, I have to say object now. I have to cast it to an object in order to be there, I think. Or, oh, sorry. Hang on a sec. Let me just remove that. obj2, let it be so. Right now it should work. And if I say, okay, this is called casting. So I casted the person into an object. And if I would like to uncast it, cast it back, I could say person p2 equals to obj2. And I have to cast into a person. Sorry, let it be that way because it's going to be a little bit confusing. So let me put it that way, like here. Why do we need to cast it? Okay, no. No, it isn't. Isn't obj2 is a type of, it isn't not. It is not. Now, person is of a type of obj2. It's the object type right now. By the way, just to clarify this, so for you to see why would you do such a thing, do you understand the difference between those two? Unboxing and boxing and casting. Unboxing and boxing is happening between when you put, or let it be, I will just use, just for the, how can I say, pedagogical reasons, casting and uncasting between a value type and a reference type. Casting here is happening between two reference types. They call it here casting. In here they call it boxing and unboxing. Are we good? Are we good with this definition? Understood. Also, there is an MSDN, my favorite, describes how and how it even happens in the memory. But can we make an analogy between casting function convert in MySQL? No, honestly, right now it's beyond my knowledge, especially when it comes to SQL. No, I was trying to think, but okay. Okay, no problems. No, but honestly, no. When it comes to, working with objects in SQL, it's I'm not. It's outside of my realm right now. No problems. This is boxing and unboxing. I think casting is somewhere. Actually, casting is going to be probably another. Oh, there you go. Casting and type conversions. So explicit conversions and all these stuff. So this is good in the end. This is a sort of forcing one class into another. Honestly, you see, you can see them in different ways, but if you look at them correctly, this is the polymorphism. This part is polymorphism. Because a person is a child, the person is a child of an object class. So basically, I didn't even need to do this. I even didn't need to explicitly say this. I didn't need this explicitly to say it, because anyway, it sees the person object as the parent one. Okay, so this is more like that. Okay, since we understand the difference, let me go ahead over here and talk about collections a bit. I would like just to know this regarding this frame, because you're going to see this boxing and unboxing happening live right now. Any questions regarding this part? Okay. Honestly, I see a lot of people, like 15 guys or girls. I don't know if we have girls among us, but I see. Oh, there's Selma. Okay, there's one girl among us, but I don't know if all of them are AFK. So it's gonna be whoa. Because I say if all guys is gonna be a bad idea, so I don't want to treat everybody, so nobody will feel offended or anything. Okay, and apparently AFK, since she is not even replying to the chat messages. Anyway, let me go ahead and cover collections. However, I'm not going to cover the the generics part. I will cover the normal, the first kind of collections when they appeared. Let me just type this. I will answer your question, Vladimir, in a second here. Collections. Now let me see. Does P inherit all methods and functions which object class have? Yes. There you go. Before, let me go ahead right here, even before P dot equals get type, get hash code, and to string is actually inherited. Even if you see this I, if I hit I dot, okay, you get this also coming through, but basically have equals, get hash code, get type, and to string. These stuff are coming from somewhere else. I think if we control click here, yeah, it's probably attached to one of those interfaces, I think. Type code. Yes, basically, indeed. Every class, as I said, any class that you create and any class that exists in .NET Framework, all of them, they inherit from object automatically. without any, questions. Which leads us, indeed, this is the Papa class. This is the godfather of all classes, which everybody reports to. Now you can have, hang on a sec. Hang on a sec. I think you're gonna love this reference. Wait a second. No, wait. You can think of this guy as the class. There you go. So he is the boss. He's the president of all, classes. So I think you will never forget this, right? This reference. Whenever somebody talks to you about object, there you go. You just immediately remember it, right? Sure. Thanks, Salih. I'm not, but hey. Class of yes. All right. No, it isn't. But what I want to say is, programming is like Lego bricks. It's something which you, or like a plant. It's something which you grow. It's something organic, something beautiful. So you have to have fun with it, rather than being just, kind of something that's rigid and hard. It isn't. It's something like it deforms. It grows. It's beautiful. So okay, let me go ahead with the. It has life, indeed. Okay, let me go ahead with. Now with the collections here, shall we? So if I define something like my favorite victim all the time, I presented in all classes. An array list is technically something like vector in C++, which a collection which is automatically expands all the time. An array list. Array list is let's say the array list is more like the non-generic collection, and list is the generic version of the collection. So you can specify something really strongly typed, which nothing can pass through other than a specific type you defined at the initialization. We're gonna cover it, so don't worry. For those who don't know about it, don't worry, we're gonna cover it next time. All right, so we have an array list. Now, an array list, if I say array list dot add, you see what it takes? It takes an object, right? You see, .NET Framework, okay, here's the thing. In the world, you have two types of programmers. You have a programmer A and a programmer B. Programmer A, who is creating the .NET Framework, the people who created the collection classes like array lists, stack, queues, all these data structures, integers, strings, all these stuff, all of them are made by this programmer A. Programmer B is you who is using or utilizing these stuff which has been created by programmer A. Now, when you are writing a framework for some generic purpose, you could make a list. You would like, for example, you as a programmer, you would like to create a list of integers. Some other people would like to create a list of persons. Some other would like to create a list of strings. Okay. Now here's the problem. If you are, as a programmer, trying to create for other programmers a library that handles, for example, arrays that can hold different types of objects, right now you are writing a generic kind of code that can reform and accept any kind of, how can I say, any kind of purpose. So for you, you would like to have an automatically expanding array. However, you will run into a problem that people have to specify what kind of object is going to be passed inside. Now the problem is, the programmer outside, I mean the programmer who created .NET Framework, he will not sit down and imagine all kinds of that could be created. So he will not create for you a person class, he will not create for you, I don't know, a car class or a building class. He will not create those for you. Say for building, you're gonna have to say, okay, array list building, and right now this array list can accept only buildings. This is not possible, and this is quite tedious, and actually at the same time it's kind of stupid. So what people do is they'll start writing a more or less a generic code that can reform and accept anything. Okay, so they utilize the idea of that since every class that you created and any class that exists in .NET Framework, all of them they inherit from object. They have just simply utilized the polymorphism, and they said, okay, if I would like to add something into my array, it will just accept object. And since by the polymorphism rules, if anything, any of the child classes being passed inside this function, it will be always acceptable. However, in our case right here, if I pass in 10, right now I have a, let me just put space. Can I draw? Okay, awesome. Right now, this is an array, this is our array list, okay? And what you have done here, you have automatically boxed 10 inside. You see? No, not the list of 10 integers. You have added in the first time. This is your array list, and when you said add, you added right here, or at the beginning. I mean, I don't care about the position of it, but with the concept. 10 in a box and put it in a shelf. Indeed, sir. Indeed. Great, great. Now, for those who are asking to use inboxing and unboxing, or boxing and unboxing, this is the reason why it happened. Indeed, sir, quite exquisite. So basically, if I say, oh, hang on a sec, sorry. Apparently, I have some. Okay. Rlist.add 20. Rlist.add 30. Okay, so basically we have three numbers, three integers, and they have been added right here, right? They have been boxed, so this is 20. Drawing with a mouse, just keep up with me here. Okay, and this is 30, and the box is getting smaller and smaller reason. Anyway, so basically, this is what in fact happened. So you have added 3 items, 3 integers into your array. Okay? And since you are adding them inside this array list which accepts only objects, and since an integer inherits from object, by rule of polymorphism or rule of inheritance, it can actually access and can be added right here. So it is basically completely syntactically and logically correct. The problem is, we would like to get them out again. Now, if you would like to get them out, you have to unbox them. So I'm going to have to say rlist of index 0 equals to an integer. Sorry. Sometimes when I get carried away. Int x equals to this guy. List of 0. There we go. Right now I unboxed it. Right now if I say console.writeLine, oopsie, I say x, and for a second here let me just comment those guys. So Control KC. Control F5. You see, I got 10. And if I go ahead and say 1, Control F5, and I get 20, right? Use for loop. Exactly, we can use it. So we could do like this. For int I equals to 0, and I is less than rlist dot count or length, I think, or then count I plus plus. Actually, yeah, I commented it here, so that's why I can use it, I think. And then I say check line rlist of I, and all of it is being casted to an int. By the way, it's automatically going to be printed out because it's going to be automatically casted. I think so, because it's a primitive type anyway. It's going to be do that. However, I will just keep it that way. I'll just keep it here just for clarification purposes. Okay. So I hit Control F5. This is how it will work. Okay. Now, there's something new came out with C#. We had while loop, we had for loops. While loops with its two types, so while do and do while. Actually, while and the do loop and for loop, we have them. And for those guys who are interested, and I told this to the previous class, does anybody know how to create an infinite loop? I wanted to ask people just for fun. No, using for loop. Creating an infinite for loop. Yes, thank you, Vlado. So basically this. Right now, you have an infinite for loop. Awesome, right? We are playing a game. Any game in the world is created inside an eternal loop. Basically, it's an infinite for loop. And it's not a for loop, but basically it's an infinite loop. Exactly, Imad. Now I'm talking about what I would like to talk about is the new one which came out with C#, which is called the for each loop. Now also it exists in Java, by the way, so for you, just for you to know. And basically, when we are trying to for each over a loop, for each over a loop, for each over a collection, sorry. Yeah, exactly. I also presented this in the materials. How about this? Control N. And I always said, I always give this example all the time, the tree and the monkey. I think everybody knows about it. Nope, if you don't know about it, raise your hand. I always enjoy it, by the way, this tree and the monkey example. It reminds me of home, you know. Africa, not Egypt. Egypt is completely deserted, so everything is deserted, almost. So this is the tree. Hang on a sec. Which one to choose? Let it be this one. All right. And we have got color. Okay, let it be. What color I said? I will even choose greener. Okay, I know weird apples, but what you could do. Okay, well, monkeys are grayish, black, so I'll just grab a dark gray. GMO. GMO stands for Aha, okay. Genetically, exactly, is genetically modified one. Okay. So yes, genetically modified, and as well a genetically modified. We have a genetically modified monkey as well, which is going to be kind of scary. And I don't know why. I cannot draw. I'm really basically awful at drawing. And we have his tail. Don't ask me how come the tail looks like this, but I need to draw the purpose here of all the pain and agony which I'm going through. And we are, monkey name is Colin. My man is gonna be Colin, just for you. Okay, so let's say for a second this is Colin. Always have fun, right? And he loves long walks and moonlight. Okay, so there you go, enough of the background. Now let's talk about the actual purpose of the guy, right? So, so Colin here, it's kind of strange. This is really... Okay, so basically, okay, Colin over here, because it's a boy's name, so it's going to be a he. He needs to go over and grab. Colin is having a problem over here. He has to have a bucket in order for him to bring you the tree. So basically, Colin here is your for each. The tree is your collection. The GMO, the genetically modified apples which you see over here on the tree, are the actual items in your collection. And one of the rules that Colin implies, because he's kind of, how can I say, not very smart, he says, anything which I like to grab items, the type of the items which I'm, has to match the type of the pocket which I'm, or the bucket which I'm actually grabbing the item. So if I have a bucket which can hold the type of apples, green apples, the genetically modified green apples, it can only hold this genetically modified green apples. It cannot hold orange. Okay? So it has to be that way. Ninja. Thank you very much. Right now I cannot see it as a monkey anymore. Thank you. Now, basically, Colin, go ahead and fetch every item one by one. And it will come back to you. He will come back to you and show you the item. You put one item for something else. It in fact shows it to you. Okay, and this is it. And goes back, so jumps off the tree, grabs the thing for you, shows it to you, and then goes back again for the next one. And it does the items. So that's why it's called a for each loop. There's a very, very important thing you have to understand. You cannot swap the objects. You cannot say, okay, Colin, you got me that green apple. Right now that green apple becomes an orange. This is not allowed. You cannot do that. For each loop is a read-only loop. It goes one by one. Yes, it goes for each apple one by one. Or actually, for each item one by one. And the for each loop, by the way, works over collections or over classes, basically, that implemented the IEnumerable interface. Let it stay Apple, we learn easier. Okay, it is Apple, don't worry. Just imagine it whatever you want, sir. Let me grab for you something very interesting here. Also from MSDN. IEnumerable interface. Excuse me. This is the IEnumerable interface. It has several methods, extension methods for now. We're gonna learn somewhere in semester later deep. However, there is very important thing. People, for example, they have a demo here. People implements the enumerable interface. Remember, I said if you would like to implement if you would like to go for each loop, works on classes and collections that have implemented the enumerable interface. And I'm showing to you this because I wanted to say that again, and I'm emphasizing on it. You cannot modify, you cannot swap that object. You can modify some of its properties, but you cannot swap the whole object. So why I am saying that? Because when you are saying when you are doing a for each loop, you are whenever Colin is actually getting the apple from the tree, the bucket which he gets into it, the object, and returns it back to you to see it. This is it. Get me the current object, which is there you go. This is basically this is the implicit and this is the explicit. Sorry, this is explicit and this is the implicit, I think. Or yeah, okay. This one calls basically. So this is the explicit implementation, and this one calls this one. Okay, so to be clear. Now, as you can see here, you are just only getting it. It's a get. You say there's no set. Okay, so this is very, very important. You can modify this green apple to make it as a little bit larger apple, but you cannot swap it to make it an orange. It's not possible. Okay, because it's a read-only property. Okay, so that's why I'm mentioning this. Honestly, I didn't want to implement the enumerable interface. It could be a little bit away from the scope of the class, but this is very important to prove why for each loop is some sort of a read-only loop. You cannot modify. If you would like to modify the whole thing, swap an object for another one, like make the apple becomes an orange, then you're gonna have to use the regular for loop, the normal for loop. So for int j or int k equals 0 and k less than the size of the array, then k plus plus, and then you start writing in your own code to swap actually to make this tree, instead of trees of oranges or trees of apples, as you can see here, to make it a tree of oranges or bananas or whatever. Okay, so this is just proving out why for each loop is a read-only loop. Okay. Okay, so it's one. Let me see here. Hang on a sec. Enumerable interface. Yes, please do not forget that name, because I'm going to return back to it later in the middle of the semester. Remember that name, the enumerable interface. That interface, in fact, this is very, very important interface. It plays a crucial role in all stuff which we're going to utilize in .NET Framework later on in the semester. Okay, and now this is how a for each loop will look like. So if I say integer, I'll leave it item in my array list. I'll just simply say console.writeLine item, right? By the way, this is, I think, already casted right away. Okay, so if I hit control, actually unboxed automatically. So I hit 10, 20, 30. Okay, so this is how a for each loop works. Now here's one more problem, and a very huge one. It created a lot of headaches for a lot of programmers, because the add function actually accepts an object, any parameter or any type of a type object. If I add a string to a type of object to array, you can. This is the problem which I'm talking about right now. This is for those who read, you know, rage comics, right? So suddenly, you get a string appearing in the middle of the collection. This right now, what you see, perfectly plausible. Perfectly fine. It should work. This is how a string class inherits from the object class, and by the rules of polymorphism, it should pass right away. However, this loop, it should break right away. So if I hit Control, let me keep connecting. You know, rlist.add 40. Control 5. Now you see, your program starts to crash, and it says invalid cast exception. It cannot cast to it because this is not an integer. How we can resolve this problem? It breaks when it hits the string. It just, you know, it's fine with the integer. So as I told you, it just goes over every item on the array and just brings it back to you. Okay. Now, because this is how for each loop works, you have to specify the type of the bucket before you go upstairs. If the type of the bucket mismatches, so suddenly a wild string appears on the tree for each object item. Now it will work. Of course it will work. And now if I say this, you mean this? It should work right now. var, I will talk about the var later in the semester. The implicit and explicit typing. Okay? By the way, be careful when you are playing with these casting and uncasting and all these stuff, because how the stuff works here. Now, how do you? Yes, true. How do you protect yourself as a programmer from such problems? You know, you have to right now start specifying or creating strongly typed collections. This is what people with C# 1.0, what they were doing. They were having to create some sort of another, how can I say, version of array list. They inherit from array list, and they start making their own rules inside before you are actually adding any objects inside. So you say, okay, I'm making a collection of integers. No one except integers should pass. Now, memory overhead, performance overhead, because right now you have to check every time, are you that guy or are you not? If you are that guy, then you have to do something else. If you are not that guy, you have to do another thing. And everything is happening in real time. And most of the time, you would like to keep your exceptions and your type definition most of the time in runtime. I wouldn't, well, basically it was. I mean, this is the only way to solve it. You didn't have anything to do against it, because these are the collections. You couldn't do anything more until generics came, and right now you don't need to do this anymore. By the way, with generics you specify a specific type, you know, and you go just with it, and this is it in the next lesson. All right, so this is basically it. So basically you have to be careful when you are having a collection of such a thing, and then you're trying to you know, start working over it with, or start looping over it with a for each loop. You have to be careful how your collection looks like from the inside. Now, of course, if I pass in here, it will also work just fine. Oh, can you hear me right now? Are we good? Okay. We are hearing a noise. We're good. Are we good? Okay. Tango's down. Nope, not down. Now if I hit Control, you see I get this problem again. Okay. because due to the polymorphism it passes over here. Okay, so this is basically, you have to be careful when you are casting them back. Of course, I'm going to right now put an object, and it will work. But of course, right now I get the namespace dot the class. Actually gets you the path of it because it calls the object dot to string automatically. Okay, so I think this is it when it comes to boxing, unboxing, casting, and for each loop, because all of them, I think all of them, they are related. Boxing and unboxing, casting and uncasting, and looping over some sort of a collection that looks like this. These are the points which I wanted to cover.